I watched this video today by Alex from the Outdoors55 channel, and it's really misleading. Effectively, nothing that he says is correct in this video, and I just wanted to make a constructive criticism video using the Science of Sharp website to pretty much just debunk everything that he says. The video is called "Does Knife Sharpening Direction Matter?" So obviously he's talking about sharpening direction and how it affects building a burr. But before we talk about that, I want to change some of the nomenclature he uses in the video to make it less confusing. So Alex talks about sharpening forwards and backwards, but we're going to refer to that as edge leading and edge trailing respectively. Alex says that people believe that edge leading strokes don't create a burr and that edge trailing strokes do create a burr. Now, it's obviously nonsense because everyone knows that abrading steel in any method will create a burr, which grows on the opposite side of the abrasive surface. Effectively, what Alex says during this video is that both edge leading and edge trailing will create a burr, and therefore there's no effective difference in the technique you use, so just do whatever you like. He then goes on to say that even if edge trailing did create more burr, it wouldn't matter because you could just spend an extra 40 seconds stropping it off. I mean, there's loads to unpack here, so we can do it one step at a time. First, I'm going to talk about the burr, then we'll talk about removing the burr, and then we'll talk a tiny little bit about extra stropping to remove a burr and why that is not always good and why it doesn't even always work. The stage of sharpening where the direction of sharpening clearly does have an effect will be on the final few passes where you're either deburring or minimizing the burr. I'm not going to use any of my own thoughts for this video, I'm just going to completely plagiarize Todd over at Science of Sharp, and we'll really quickly clear up what a burr is. So a burr is raised by repeated abrasion of one side of the blade, and the burr will grow in the direction that is away from the surface of the hone. And there is a picture for you that have never seen a burr before. This is why it's so important for Alex to have specified the stage of sharpening he was talking about, because the burr which matters is the one that you're left with once you leave the stones, not the one that is there during the early stages of sharpening. You can see here that Todd mentions that the terms wire edge and foil edge are often used interchangeably with the term burr, but they are usually associated with edge geometries that are created during the finishing stage, and that's the important part when we're talking about a burr, is the finishing stage, not, for example, the bevel setting stage. I think this is where Alex has gone wrong, in that he's confused himself with a foil edge and a burr. If we jump over to the Pasted Strop Part 1 article, we can learn a bit about this. So just a moment ago, we read that sometimes burr, foil, and wire edge are used interchangeably depending on what stage of the process you're in, and that when it's a finishing stage, it is generally referring to a foil, which is a much smaller burr. And so here Todd says that when honing a blade in the edge leading direction, steel is removed in two ways: abrasion of the bevel surface and the breaking or micro-chipping away of the apex. This micro-chipping process prevents the formation of a burr, actually a foil, but also limits the level of keenness that is achieved, and Todd is referring to keenness as thickness of the apex. So in edge trailing strokes, the occurrence of micro-chipping is reduced, which means that the edge can get keener, and this happens to a point where a burr or a foil will almost inevitably be formed. Here we have some evidence to back up the statement by Todd. He's done a number of images with a 1K and a 16K stone, edge leading and edge trailing pairs. So this first image is of a 1K stone, 20 alternating edge leading passes, and you can see there's no foil on here at all, and the apex is in the range of 0.5 to 1 microns wide, and so it's going to be wider than the edge trailing ones because the steel was chipping away. This is the edge trailing example down here with the 1K stone, 20 alternating passes again, and there has an edge width of 0.1 micron instead of 0.5 to 1 micron. So it's far thinner because it wasn't chipping away, and you can see there is a foil edge on this. It was created by the edge trailing passes. You can see here he's got more images showing this foil edge from the edge trailing passes. A foil edge can be very difficult to remove because it usually involves sacrificing some keenness to remove it. It's when the steel is that small, it becomes very flexible and it can't work hard and off or really easily be abraded unless you increase the angle near the apex. Todd shows this in some of his other articles, but this video is getting long enough as it is, so I won't go over them here and I'll link them in the description. It starts to get a bit more confusing as we move over to the burr removal article, but here we can see an image of a knife finished on a 1200 grit diamond plate using edge leading strokes, and Todd mentions that a subtle burr which is too small to see with an optical microscope is produced. If we scroll down a bit, we can see another image of the same knife finished on a 1200 grit diamond plate again using edge trailing strokes, and Todd specifies that a burr large enough to be seen with an optical microscope is produced. And keep in mind, Todd is using a scanning electron microscope here, so we're seeing much, much larger magnification. And this burr is clearly a lot larger that you can see here. So I imagine that has been chipped away on this edge leading stroke image. So basically what we've learned here is that if you are doing your burr removal or burr minimization with edge leading strokes, you can produce a burr which is so tiny you cannot see it with an optical microscope. If you are trying to minimize your burr with edge trailing strokes, you will create a much larger burr, so much larger that you can in fact see it with an optical microscope. So debunking the last bit of what Alex said, which is just strop a bunch to remove the burr. If you have a look around on the Science of Sharp website, Todd clearly shows that you cannot remove a foil edge in most instances from stropping. The only way to do it is to micro bevel it or cut a fresh edge. So that, that debunks it enough as it is. But going even further, potentially you are trying to maintain a toothy edge so that you have more utility in a draw cut. And stropping a bunch is a surefire way to remove the tooth. I don't want to go into that too much now because I personally can't do it justice, and it's an entire video on its own, but it's pretty evident from this video that there is a significant difference between edge trailing and edge leading finishing strokes. I know some people will be saying that a tiny foil edge will just tear off and it doesn't matter. It can tear off. That will leave you with a less keen apex. It will be thicker. And in some instances, it can even damage the underlying apex. Todd has an image here where that exact thing has happened. The foil is fully removed from cutting through some bond paper. So the foil was fully removed, but it rolled over and damaged the underlying apex. So that's, I don't know what to say. It's pretty clear. I think that pretty much covers everything, but I'll leave you with one last thing, which is Alex thinking that he's got an electron microscope, even though his pictures are clearly from a macro lens.
So we can just feel a burr, and then we'll look at it under the electron microscope.
Okay, so
I mean, clearly none of this matters because his sharpening theory is pretty much trash, and yet he manages to get some really good edges, so I guess just do whatever you want.